All right, welcome back to part 4. So in the last installment, we found the sine and cosine of the double angle, but we left off at where we were using the cosine of twice theta. We found that's cosine squared theta minus sine squared theta. And we substituted for cosine squared theta 1 minus sine squared theta. And we subtracted that from sine squared theta. And when all the dust settled, we got 1 minus 2 times sine squared theta. So we can say that, oh, let's do the second one while we're at it. Okay, and then we substituted for sine squared theta. So it's cosine squared theta minus 1 minus cosine squared theta. And when all the dust settled for there, we got, remember, all the signs flip, minus, and that becomes a plus. We added the cosine squared thetas together, then we have the minus sign and back. Okay, so 2 times cosine squared theta minus 1. Okay, so let's rewrite those. Okay, so okay, so cosine of the double angle equals 1 minus twice sine squared theta. So as I stated in the last video, we're going to solve for sine squared theta. We're going to solve for sine squared theta. So we want to isolate, get everything, isolate sine squared theta. So move everything else to the other side of the equation. So what I'm going to do, just to keep it orderly, I'm just going to rewrite it. I'm just going to rewrite. Okay, I'm just going to turn it around. So I'll write 1 minus twice sine squared theta equals cosine of twice theta, or 2 times theta. Okay, so first we could subtract a 1 from both sides. So we subtract the 1, this cancels, that cancels. So we have negative 2 times sine squared theta equals cosine of twice theta, 2 times theta minus 1. Okay, we can now divide out this negative 2 from both sides. So the negative 2's on the left side cancel, and we're left with the sine squared theta, and that's set equal to minus cosine twice theta minus 1 over 2. Okay, so note here that we had a negative 2 in the denominator. So let's isolate that. We don't want to leave it like this. Let's use parentheses, because negative 2 is equal to negative 1, right, times 2. It doesn't matter where we set the negative. We could bring it upstairs, right? Okay, so there's a negative 1 here. So we multiply the negative 1 times cosine twice theta. It's just going to flip the signs. So we get sine square theta equals 1 minus cosine twice theta divided by 2. Now you can leave it like this. This is called the power reduction formula. So you're taking a power and you're reducing it, right? And when you're doing integration, this comes in handy sometimes. So we can leave it. These are the power reduction formulas. Okay, so we'll do the one for the other function, the second function here. We call that 10.2 or number 12. Okay, so let's put this one in pocket. So say sine squared theta equals 1 minus cosine, the double angle, 2 times theta divided by 2. And we'll clear up some real estate here. Okay, using a similar methodology, we're going to set cosine of the double angle set equal to 2 times cosine square theta minus 1. So first thing, we'll add the 1 to both sides. So we add that 1 to both sides, we get 2 times cosine square theta set equal to cosine of the double angle plus 1. And I'm going to write that in reverse because this is what I want to solve for. This is what we want to solve for. So let's write 2 cosine squared theta equals cosine of the double angle twice theta plus 1. And all we have to do now is just divide out this 2. Since that's positive, the signs don't flip, they stay the same. So the 2's on the left cancel. And when all the dust settles, we have cosine squared theta equals cosine 2 theta double angle plus 1 all divided by 2. So you can see where the double angle formula or where the half angle formula comes from. It's almost in this form. Okay? It's almost in this form. So let's square up. Okay, let's see here. We'll put this one in pocket. Okay, so cosine squared theta equals cosine double angle plus 1 over 2. Okay, we're going to use these to find the half angle formulas, which we can do that right now. So note that the half angle formula, the sine and cosine on the left, those terms aren't squared. Okay, so we're going to square both sides. Okay, so let's write this over. Okay, so sine squared theta equals 1 minus cosine of the double angle twice theta, all that divided by 2. Let's take the square root on both sides. You can say raise them to the 1/2 power. So we're going to get sine theta on the left, and that's just equal to plus or minus the square root of 1 minus cosine of the double angle. Now, all we have to do now, we're going to deal with the angles inside of the parentheses. So if I divide this angle by half, then I have to divide that angle by half. And when we do so, that's going to yield a result equal to sine of half angle, half of theta, equal to plus or minus the square root of 1 minus the cosine, right? 2 over 2 is just 1. That's just going to be the cosine of theta. And that's divided by 2. Okay, and using a similar process, so let's put this one in pocket here. So the sine of half angle, sine of half angle equals plus or minus the square root of, okay, so the sine of the half angle equals plus or minus the square root of 1 minus cosine theta divided by 2. Okay, let's finish up with the next half angle identity. For cosine. So we're gonna use a similar process, very similar. So if you can do one, you can do the other. All right, so we have the cosine square theta equals the cosine of the double angle, double theta, plus 1, all divided by 2. So we'll take the square root, both sides, and that's going to give us the cosine of theta equals plus or minus the square root of cosine, the double angle, plus 1 divided by 2. And again, we're going to divide the angle to get the half angle, right? We divide this angle by 2, and we're going to have to divide that angle by 2. It's the same angle. And it comes out of the double angle formula. Okay. And that yields cosine. Let's put that in parentheses. Okay, the cosine of half angle, half the angle, equals plus or minus the square root of cosine, right? 2 over 2 is 1 again, of theta plus 1 divided by 2. Okay, then we'll put that in pocket. So these identities are very useful for taking Calc 2 and integrals of trigonometric functions. These come in really handy. They're really good to know, good to derive. It exercises your mind, and it also helps you master. You derive these a couple times, and they'll be stuck in your memory. Okay, so I think that brings us up to 14. Okay, so looking back at our list of functions, okay, looking back at our list of functions, okay, so we've derived the reciprocal identities. Those were given. We did the Pythagorean identities. We did the sum and difference, the double angles, and then the half angle identities. The product identities, just to give you a hint, the product identities are derived from the sum difference identities. The sum difference identities, you can derive the product identities using the sum and difference identities. And that will do it. That concludes the series. So in another video, we'll do the tangent functions for those. And we'll also derive the product identity. That's it for now.